Hey, and welcome back. We're going to continue with equations today, and we're going to look at when there's variables on both sides. So hopefully this is your review from your earlier equation studies, maybe in 8th grade math. When solving an equation with variables on both sides, you want to isolate that variable to one side using inverse operation. So I've got letters on both sides. Our first step is to make sure those letters are on the same side and using those inverse operations. I've got 3 whopping examples, and that should get us covered for variables on both sides. Let's look at number 1. 6x plus 3 equals 9x minus 12. You've got 6x on the left and 9x on the right. I suggest always looking for the smallest one. So in this case, the 6x on the left is our smallest. It is positive, so I will subtract 6x from both sides. I'm going to zoom in a little bit on this. There we go. So 6x minus 6x cancels out. So all that's left now is the 3 on the left side. And then 9x minus 6x. Those are like terms. So those are the ones I can combine. Gives me 3x. And the minus 12 was a constant. Didn't have anything to combine with, so just bring it on down. So there's my equation. And now it looks like a two-step that we've done before. I want to add 12 to both sides. 3 plus 12 gives me 15 equals 3x. And then finish isolating x, dividing both sides by 3. 15 divided by 3 is 5. And as we have mentioned before with equations, you can always check your answer. So if I plug in the 5 in place of x in the original equation and simplify, these two sides should be equal. So let's see, 6 times 5 is 30. Plus 3 would give me 33 on the left side. So the right side should equal 33. Let's see, 9 times 5, 45, minus 12 is 33. So it did equal the same thing on both sides. So those expressions are equivalent to each other when x is 5. Does that make sense? Let's look at the second one. Negative 2x minus 9 equals x minus 21. All right, let me grab the highlighter. We have the negative 2x and a positive x. So I said before, one, I like to move my variables first. I think on Delta Math, if you look at their steps or you watch their help video, I think sometimes they move the constants first. I really don't like that because sometimes the variables cancel out, and that's a unique thing. But I mentioned in number 1, I like to move my smallest variable first. Which one's smaller? The negative 2x is actually technically smaller. So I'm going to use inverse operations to get rid of that negative 2x. So it's negative. I'm going to have to add 2x to both sides. Cancels out. On the left, negative 9. On the right, this was 1x plus 2x gives me 3x minus 21. Looking like a two-step. From there, isolate the x by adding 21 to both sides. Negative 9 plus 21 will give us 12 equals 3x. Divide both sides by 3. 12 divided by 3 is 4. I'm going to bring it on up, and let's plug it back in. Negative 2, plugging in 4 for x to check my answer. On the left side, I'll get negative 8 minus 9. That gives me negative 17. So I need the other side to equal negative 17 for this equation to be true. 4 minus 21 is negative 17. It does check out. So these were our final answers on 1 and 2. All that's left is number 3. On the left, there's a negative x. On the right, there's a negative 4x. Which one is smaller? Negative 4x. So I would get rid of that one. My suggestion to you, let me erase our highlights there. Add that 4x to both sides to cancel that out. I also like to eliminate the smaller one because notice here, I'm adding 4x. I'm helping things to become positive. Look, when I combine negative x plus 4x gives me positive 3x. Anytime I can avoid negatives, I'm for it. Those negatives can be tricky sometimes. Bring down the minus 8 equals negative 23. Don't forget that that minus sign is attached to that 23, giving us a negative. From there, finish your two-step, add 8 to both sides. Negative 23 plus 8 gives us negative 15. Divide both sides by 3. X equals negative 5. Let's check it. Squeeze it on here. Let's see. Now, careful. Our original equation was negative x. So there's a negative, and then I'm plugging in my x value of negative 5. Equals negative 4 times x minus 23. So the negative 5 makes a positive 5. Minus 8 is negative 3. Let's see if the right side equals negative 3. Negative 4 times negative 5 is positive 20. Minus negative 23. It does. They equal the same thing on each side when x is negative 5. So those are variables on both sides. I tried to pull some of the tricky ones. Remember, these notes are directly from Delta Math. So these I pulled from Delta Math. Maybe you'll come across them. Maybe you'll be lucky and you'll see the exact same problem. It is totally possible. Let me know if you have any questions. We'll practice this and talk about it in class, and I'll see you then.